Hello there, Mr. Sutton here, bringing you the IM3 7-3 Part 1 homework solutions on right triangle trigonometry. On this one, we're trying to find this missing side of a right triangle. Now, we only have one other side to work with, and the angle they gave us is not one of those special angles like 30, 45, or 60, so we have to use SOHCAHTOA for this. So we've got the, we don't have the hypotenuse. Instead, we're looking for the side across from the angle, the opposite side. We have the adjacent side, the non-hypotenuse leg. With opposite and adjacent involved, that's going to be the TOA part of SOHCAHTOA. So we have tan equals opposite over adjacent. So we can write tan of our angle, 65 degrees, equals the opposite side across from the angle, the x there, divided by that adjacent side, that touching side of 9. And to get x, we're just going to multiply both sides by 9. So we've got 9 times tan of 65 degrees. Let's use the calculator for that. So we've got 9 times, here's the tan button, 65 degrees, and enter. That gives us about 19.3 if we round to the nearest tenth. For this problem, I'm trying to find the hypotenuse of a right triangle where I only have one side given, and it's not a special right because we don't have a 30, a 45, or a 60. So it's SOHCAHTOA or bust on this one. Specifically, since I'm looking for the hypotenuse and I have the side that's across from or opposite from the angle, opposite hypotenuse means we're using SO from SOHCAHTOA. So we have sine equals opposite over hypotenuse. So then we have sine of 53 degrees, the angle, equaling, we said the opposite side was 11 because that's across from the angle. And then the hypotenuse is what we're looking for. That's the x in this one. Now to get x by itself, we have to multiply by x and then divide by sine of 53. So basically switching x and sine of 53. And then let's just do this on the calculator. So we're going to have 11 divided by sine of 53. And that's going to be 13.8 rounded to the nearest tenth. For this problem, we're trying to find a missing side of a right triangle. We only have one side, and it's not a special right triangle. This is not 30, 45, or 60 degrees. So let's go ahead and use SOHCAHTOA. Since I have the hypotenuse and this leg of the angle that's not the hypotenuse, that's the adjacent side. Adjacent and hypotenuse means we use CA in SOHCAHTOA. So that's the cosine function, which equals adjacent side over hypotenuse. So we can say the cosine of our angle, cosine of 48 degrees, equals our adjacent side. Again, that's the non-hypotenuse leg. So that's this 19 here. And that's going to be over our hypotenuse of x. To solve for x, I multiply by x and then divide by cosine of 48. So basically switching the x and the 48 to get 19 over cosine of 48 degrees. And we'll need the calculator for this part. So on my calculator, I've got 19, and then I'm dividing that by cosine of 48. Enter. It gives me 28.4. For this one, I'm trying to find this missing side of the right triangle. Since I've only got one side and not a special triangle, I'm going to have to use SOHCAHTOA. So I've got the hypotenuse already. I'm looking for the side across from the angle, the opposite side. Opposite hypotenuse means we're using SO from SOHCAHTOA. So that's sine equals opposite over hypotenuse. So we can say sine of 55 degrees equals the opposite side of x, that's the side we're looking for, over the hypotenuse they gave us of 13. And then to get x, I just have to multiply by 13. So we have 13 sine of 55, and now it's time for the calculator. So here we go, 13 times the sine of 55, and I don't need to write the times symbol. It understands that that's what I'm doing is multiplying. Pressing enter, we get 10.6, and that's the nearest tenth. On this problem, I'm trying to find a missing side, and I've only got one side and a non-special angle. It's not 30, 45, or 60. So SOHCAHTOA it is. Now we've got the hypotenuse here, that's 15 across from the right angle. And this other side that's not the hypotenuse, but it's still touching the angle, it's one of the legs, that's the adjacent side. So we have adjacent hypotenuse, that's going to be the CA part of SOHCAHTOA. So that's cosine equals adjacent over hypotenuse. So I can write cosine of 41 equals, we said our adjacent side was x, that's actually the side we're looking for. And then we had the hypotenuse, that was 15. So now to get x, we just multiply both sides by 15. So that's 15 times the cosine of 41, which I will now put in the calculator. So on the calculator, we have 15, we have cosine, we've got 41, and that's going to come out to 11.3. To find this missing side in the right triangle, since I have one side and it's not a special right triangle, it's not 30, 45, or 60, we're going to use SOHCAHTOA. We're looking for the opposite side, and we've got this adjacent side, the side that's touching the angle, but it's not the hypotenuse. So if we have opposite and adjacent, that's the TOA part of SOHCAHTOA. So that means we use tangent. Tangent equals opposite over adjacent. So we've got tan of our angle, 27 degrees, equals the opposite side, which is across from the angle, so that's x, over the adjacent side, that's the side touching the angle, so that's 15. And to solve for x, I have to multiply 15 by both sides. So x is going to be 15 times the tan of 27, which I'll now do on the calculator. So we've got 15 times tan, and I can just write it right next to the 15. It knows I'm multiplying. Put a 27 in there. Close the parentheses or not, since it's the last thing in the entry. Press enter. We've got 7.6. For this problem, we're trying to find the hypotenuse, and we're given one side and an angle that's not a special angle, like 30, 45, or 60. So in this situation, we only use SOHCAHTOA. So it looks like since I want the hypotenuse and I have the non-hypotenuse leg of the angle, the adjacent side, I'm going to have to use CA from SOHCAHTOA. That's cosine equals adjacent over hypotenuse. So we have cosine of 67, and that's going to equal, we said the adjacent side was this non-hypotenuse leg, so that's 15, over the hypotenuse that we're looking for, that's x. To get x, I multiply by x and divide by cosine of 67. So we have 15 over cosine of 67 equaling x. And now it's time for the calculator. So plugging this in, we got 15 divided by, we said cosine 67. Enter to get 38.4. On this problem, I'm trying to find this missing side of the right triangle. Since I only have one side to work with and an angle, and it's not one of those special angles like 30 or 45 or 60, I'm going to have to use SOHCAHTOA for this one. So let's see what sides they gave us. Based off of this angle, we have the side across from the angle, the opposite side here, and we have the side that's adjacent to the angle, the leg that's not the hypotenuse. So if we have opposite and adjacent, that's the TOA part of SOHCAHTOA. So that's the tangent function, tan equaling opposite over adjacent. So we can say tan of our angle, tan of 25 degrees, equals the opposite side, that's the side across here, 8, over the adjacent side, the leg of the angle, that's the x here. And in order to solve for x, I'm going to multiply both sides by x and then immediately divide by tan of 25. So basically switch the x and the tan 25. So then if we do 8 over tan of 25, let's do that on the calculator. So I've got 8 divided by, and we're going to use tangent 25, and press enter. So that's going to be 17.2.